The increasing requirement for diesel engines to produce better performance whilst reducing noise, pollution and consumption has led Citroen engineers to seek solutions using direct injection technology. The objectives have been met by using common rail, which is an electronically controlled high-pressure fuel injection system, the pressure of which is varied independent of engine speed. The common rail injection system comprises electric low-pressure pump, preceded by a filter, main fuel filter, and a high-pressure pump driven by the engine. The pump supplies a constant flow of diesel to the common rail, which acts as a reservoir for the high-pressure fuel. The rail, in turn, is connected to the injectors via pipes. Each injector is then operated by an integrated two-way electro valve. And to meet the engine's constantly changing requirements, an ECU controls the fuel rail pressure, the pump flow rate, and the operation of the injectors. For each injector, the common rail system allows several injections per engine cycle and at a variable pressure. The low-pressure pump located in the fuel tank provides a continuous flow of diesel. From the pump, fuel flows straight to the filter that protects the system from dirt. At its inlet is a thermostat, which, when cold, diverts some of the fuel delivered from the low-pressure pump to the diesel heater. The heater is located in the coolant outlet on the cylinder head. The thermostat consists of a bimetal device which deflects with varying fuel temperature. Below 15 degrees centigrade, the thermostat closes the route to the filter and directs the fuel to the coolant outlet housing, where it's heated. At temperatures between 15 and 25 degrees centigrade, the thermostat divides the fuel flow, allowing some to pass to the heater, whilst the remainder is directed through the filter. At temperatures above 25 degrees centigrade, the thermostat deflects further, and all the fuel flows via the filter. The filter also houses a regulator to limit the pressure delivered by the low-pressure pump. Note also the integrated drain tap. Because the high-pressure fuel circulating around the system becomes hot, the return line includes a cooler to ensure that the fuel is cooled before it returns to the tank. The high-pressure pump, incorporating 3 radial pistons and driven by the toothed belt, is not timed to the crankshaft, which is yet another advantage of the common rail system. As the diesel enters the pump, it passes first through a safety valve, which regulates the supply to the pump. The fuel that bypasses the valve is essentially used for lubrication and cooling purposes. When the fuel pressure delivered by the low-pressure pump rises above 0.8 bar, the valve lifts, thereby opening the inlet port. This action allows fuel to fill the pumping chambers, whilst at the same time maintaining a reserve of fuel flow for lubrication purposes. Once pressurized by the pump, the high-pressure fuel is directed to the common rail and the fuel injectors. This part of the circuit also contains the fuel pressure regulator. It's controlled by the ECU and regulates the fuel pressure reaching the injectors by controlling the quantity of fuel returning to the tank. The returning fuel joins that used for lubrication and cooling. To reduce the power absorbed by the pump at low loads, the pump includes a piston deactivation system. A solenoid fitted to the top of one of the cylinders moves a control rod, which opens the supply valve. In this condition, the diesel is prevented from being pressurized, and thus it flows back towards the inlet. The reduced flow option is also initiated should an operating fault occur. Note that on stopping the engine, it can take up to 30 seconds for the fuel pressure in the circuit to drop to atmospheric pressure. The rail, which acts as an accumulator by storing a small reserve of fuel, is made from forged steel, and its volume is matched to the engine's capacity. The function of the rail is to receive the pressurized diesel from the pump and to distribute it to the injectors. The rail also houses a pressure sensor and a temperature sensor. Although the fuel injector nozzles look like those of normal multi-hole direct injectors, the top part of the injector is totally different. It houses the electrovalve or solenoid which operates the injector. The solenoid is secured by a large nut, which must not be disturbed. Slackening this nut will damage the injector beyond repair. At rest, the injector needle is held firmly against its seat by a spring. And surrounding the seat is the area known as the pressure chamber. Immediately resting on top of the needle is the control piston, which is free to move within its bore. The top of the piston opens out into a chamber referred to as the control volume. This chamber is connected firstly to the common rail by a calibrated restrictor and secondly to the return line via a similar restrictor. The return line is closed off by a ball valve on which the spring of the pilot needle presses. When the engine is cranking, and during normal running, the high-pressure fuel from the supply rail is evenly distributed between the pressure chamber beneath the needle and the control volume chamber at the top of the injector. In this condition, the injector remains closed. To open the injector, it is subjected to what is known as the differential pressure effect. This is how it works. When the ECU supplies an electrical current to the injector solenoid, it causes the pilot needle to rise. In turn, the ball is lifted off its seat by the high pressure, and diesel is allowed to escape back to the tank. This action causes the pressure balance to disappear and the control piston to rise. The needle is thus released from its seat, which allows fuel to be injected into the combustion chamber. Injection takes place whenever the solenoid is energized. Therefore, the quantity of diesel injected is determined by the duration of the electrical pulse supplied by the ECU and by the pressure supplied by the fuel pump. When starting, the engine must complete 2 revolutions for the high-pressure pump to supply the common rail with a minimum pressure of 200 bar. Once the engine starts, the ECU regulates the fuel quantity and the synchronization of the injectors by controlling the injector control current. The ECU determines the position of the crankshaft by signals from the combined TDC and engine speed sensor, and from the cylinder reference sensor. The ECU also considers information from the following sensors: accelerator pedal position, coolant temperature, fuel temperature, and the high-pressure fuel sensor. Other input signals, such as that from the airflow meter, are also required for the ECU to calculate the injection quantity. Based on the characteristic of an injector, the ECU uses a pressure and volume digital map to calculate the required injection time. A similar map is used by the ECU to calculate the fuel pressure necessary to match the engine's changing requirements. The pressure is in turn varied by the ECU operating the fuel pressure regulator on the pump. As with most electronic systems, the common rail injection system is equipped with onboard diagnosis, any faults being notified to the driver by a dashboard warning lamp. With most normal direct injection engines, noise is usually the major drawback. The noise is mainly due to the ignition delay, caused by the diesel failing to ignite immediately when it first enters the cylinders. This results in a large quantity of fuel being present when ignition does occur, thereby causing a sudden rise in pressure, which produces noise, or knock. The diesel knock is particularly noticeable when the engine is cold. In contrast, the common rail system reduces this ignition delay and in turn lessens the noise. It's made possible by variably controlling the injectors. With common rail, each injector is controlled to deliver several small injections in quick succession per cycle, to introduce the fuel more gradually. This pre-injection, which occurs before the main injection, prepares the combustion chamber in terms of temperature and pressure. and in turn reduces the ignition delay. As a result, combustion is smoother, the rise in pressure is less sudden, and the engine is quieter. The pre-injection function occurs only up to approximately 3000 RPM. In terms of exhaust emissions, this new generation of diesel engines from Citroen is among the cleanest produced. And perhaps more importantly, they offer an exciting leap forward in diesel technology, while still allowing room for further development.